Hello students, today lecture 4, aerobic wastewater treatment process, wastewater treatment in aeration tanks, wastewater treatment in biofilters. Okay, let's start. What is aerobic wastewater treatment? Aerobic treatment of wastewater is a biological process that uses oxygen to break down organic contaminants and other pollutants like nitrogen and phosphorus. Oxygen is continuously mixed into the wastewater or sewage by a mechanical aeration device, such as an air blower or compressor. Aerobic microorganisms then feed on the wastewater's organic matter, converting it into carbon dioxide and biomass, which can be removed. What is aerobic wastewater treatment used for? Aerobic treatment is usually used to polish industrial wastewater pre-treated by anaerobic process. This ensures wastewater is fully degraded and can be safely discharged in accordance with strict environmental regulations. Aerobic treatment processes are suitable for a range of industries such as food, beverage, chemical, and municipal. What types of aerobic wastewater treatment systems are there? There are several different technologies for the aerobic treatment of wastewater and the sewage. These include conventional activated sludge. Organic matter is broken down by aerobic microorganisms in an aeration tank. This forms biological flux sludge, which are then separated from the treated water in a sedimentation tank. Moving bed biofilm reactor, MBBR. Biofilm grows on plastic carriers, suspended and circulated in an aeration tank. These are kept in the tank by retention sieves. Membrane bioreactor, MBR. Advanced technology combining the activated sludge process with membrane filtration. What are the benefits of aerobic wastewater treatment systems? Aerobic treatment of wastewater is a stable, simple, and efficient process that produces high-quality secondary effluent. The resulting sludge is odor-free and can be used as excellent agricultural fertilizer. When combined with anaerobic treatment, aerobic treatment systems ensure complete contaminant and nutrient removal. This means that wastewater can be safely discharged without breaching stringent environmental regulations. What is meant by aeration tank? A fluid holding tank with provisions to aerate its contents by budding air or another gas through the liquid or by spraying the liquid into the air. Wastewater treatment in aeration tanks. In municipal and industrial wastewater treatment, aeration is part of the stage known as secondary treatment process. The activated sludge process is the most common option in secondary treatment. Aeration in an activated sludge process is based on pumping air into a tank, which promotes the microbial growth in the wastewater. The microbes feed on the organic material, forming flocks which can easily settle out. After settling in a separate settling tank, bacteria forming the activated sludge flocks are continually recirculated back to the aeration basin to increase the rate of decomposition. Why is aeration important for wastewater treatment? Aeration is most critical component of a treatment system using the activated sludge process. A well-designed aeration system has a direct impact on the level of wastewater treatment. It achieves an ample and evenly distributed oxygen supply in an aeration system is a key to rapid, economically viable and effective wastewater treatment. Types of aeration systems are two main types of aeration systems exist: mechanical aeration and the diffused aeration. Types of aeration are mechanical aeration operates from the surface of a tank or lagoon, whereas diffused aeration typically operates from the bottom. Most common aeration types: positive pressure systems. It is speculated that these are the most often used aeration systems, particularly in new steel beam installations. These systems consist of fan blowing air into the beam at the bottom, either through ductwork or a perforated false floor. Air will hit a few degrees from friction. But hot air arises and the positive pressure system takes advantage of that natural warm air movement. Negative pressure systems pull down. For the negative pressure systems, fans are located at the bottom and pull air down through the grain bulk. No power exhauster are required. Less common aeration types: pull-up systems and push-pull high air systems. Biofilter is one of the most important separation processes that can be employed to remove organic pollutants from air, water, and the wastewater. Biofiltration as a treatment technology in water and the wastewater purification. The arrow indicates the direction of water flow. Biofilters contain filter medium grains, example sand, granular activated carbon, that are covered with biofilms. The biofilm activates break down nutrients, example nitrogen and the phosphorus containing compounds, and the organic carbon, as well as capture other unwanted contaminants in the influent water. Water coming out of a biofilter typically undergoes disinfection prior to entering drinking water distribution pipes or being released to the environment as wastewater effluent. Biofiltration process. A biofilter is a bed of media on which microorganisms attach and grow to form a biological layer called biofilm. Biofiltration is usually referred to as a fixed film process. Generally, the biofilm is formed by a community of different microorganisms, bacteria, fungi, yeast, and etc. Microorganisms such as protozoa, worms, insects, larvae, and etc. And the extracellular polymeric substances, EPS. The aspect of the biofilm is usually slimy and muddy. Water to be treated can be applied intermittently or continuously over the media via upflow or downflow. Typically, a biofilter has 2 or 3 phases depending on the feeding strategy. Percolating or submerged biofilter: a solid phase media, a liquid phase water, a gaseous phase air.